So suppose I want to write a program that lets the user either enter a binary number and print out the decimal value, the base 10 value of that binary number, or the opposite, type in a decimal value, our standard number system, and get the binary equivalent, just ones and zeros. Now, that's not the largest program in the world, but what I want to talk about in this video is how do you approach designing a larger program through the example of just that simple setup, letting the user enter one of the two types of numbers and then displaying out the other type. So there's two basic approaches to this. You either have the top-down approach, where you're looking at the big picture. You're sort of looking at what is the framework that I'm going to be working inside of? Where does the information flow in? Where does it need to go? How is it going to be processed there? And then where does it need to flow out? The opposite of that is the bottom-up approach. So we're working on the details. Well, what are the particular calculations that are needed to do various number of conversions? And then we'll worry about putting those pieces together into that bigger framework. So top-down, big picture. Bottom-up, start with the details. Now, in reality, you're going to be sort of doing little pieces of both things and probably switching back and forth from the different perspectives. But I wanted to present the code in sort of an order of how might I do this with steps along with checkpoints along the way where I can test out my code. So the first thing I'm going to show is a start of the top-down framework. So I've imported a scanner. I've declared my class. Don't worry about the class name. I have idiosyncratic names for these for organizational reasons. In main, I'm going to declare a new scanner and initialize it. And I have an integer selection that I'll be using to get information from the user. Big picture, I've got a do while loop right here. And this do while loop, I'm going to repeat as long as the user wants to keep entering more values to convert from one to the other. Okay, so I'm going to print out, I'm going to prompt the user. Do you want to enter the number 1 if you want to convert decimal to binary, enter the number 2 if you want to convert binary to decimal. Now, not stated here, but if anything else is entered, then the loop will end. As you can see, that's the condition on the while loop down there. So we'll keep looping as long as the selection is 1 or the selection is 2. So then I read in the user selection from the user, and then I have an if-else if. If the selection is 1, and I just have a comment, convert decimal to binary, and I just print out that that's what I would be doing. Same thing for selection 2, except it's binary to decimal. I just print out what I would be doing. I want to work in stages that have very obvious testing points built in along the way. You've got to be running your code, executing it, compiling it, then executing it, testing it very, very regularly. Otherwise, mistakes can build up that can be difficult to solve. And then I think I've just got like a bye-bye, and I close off the scanner at the end. Now, I've already tested this, but let's just pretend and go through the process. So I'm going to move over to my command prompt. So I'm compiling it. Should be no problems, but this is the sort of thing you want to be in the habit of checking. All right, I run it. It says enter 1 to convert decimal to binary, 2 for the other one. I'll just say 1. Prints out what it would do, prompts me again. 2. Prints out the other thing, prompts me again. I say any other number. Hit enter, bye-bye, we're done. Okay, great. I've got my framework. That's the top-down approach. Yes, there were certain details of it, like creating the scanner and reading in the input, but it hasn't actually done either of the things that I really want my program to be doing, but it's the user interface, right? So that's one piece of the puzzle. So now let's look at a different piece of the puzzle. So this is a different class. It also imports a scanner and creates the scanner, and I've got some values here, an integer, a decimal number, a string for the binary number. And then I also prompt the user for a binary number, and I'm going to read it in as a string. So we're going to take our 1s and 0s in as strings and deal with them that way. The decimal numbers will just use a regular built-in integer. And I'm not actually even going to do any of the conversion code right here. I just have a comment, and I'm going to print out whatever number was read in. This is a very basic framework that I'm going to use for testing my conversion from binary to decimal. It doesn't even do hardly anything yet, but it's that framework, and I can test it. Am I reading in the numbers properly? And just that, really, and that's fine. We want to test these small things. Now, I'm not going to worry about running it because it's so small, and I'm not writing this code in front of you. I've already produced it. You can pause the video if you want to read the code in more detail. Next file, moving over to, I've got the exact same setup for the decimal to binary, except I'm reading in an integer. Next int is the scanner method I'm using, rather than a string. And again, it's just going to echo it back out to verify that this is working correctly, right? So these are my framework files, and they're also separate files. That's another tool that you can put in your toolkit. Don't try to cram everything into one Java file right away. Put it in separate pieces, test those pieces. Being a good programmer is largely about being organized and being patient to avoid the many mistakes that are very easy to make. All right, next file we're moving on to. Now, this is potentially where I would have started with a bottom-up approach, where I'm now going to just write the binary to decimal conversion code. I'm going to write that and get those details working before I try and put it into the user interface. Now, instead, though, what I've got is I took the framework from earlier, the reading in of the information and just echoing it back out, and I filled in the details of the conversion. I've also got some more imports, some of which I'll be using more later on, the math and the stack. But I know I want to use those, so I kind of just filled them in when I was ready. All right, the first part of this is the same as before. It's just the scanner and creating some variables that I'm going to use later on. Scrolling on down. All right, and here's the only code that I added. It all fits on one screen. That's also a nice feature. I will run this and test it. But let's also talk through the algorithm. So I'm going to have x here, which is eventually going to be my result integer. That is going to be the output. So I'm binary to decimal. This x is going to hold that result. An exponent I'm going to need to keep track of right here, starting at 0, excuse me. My for loop. I need to access the digits of my binary number, and I want to start from least significant to most significant. There are other ways to do it. You could go the other direction, but this is how I'm going to organize mine. Least significant digit, if that's a 1, I'm going to multiply 1 times 2 to the power of 0. Next digit is going to be multiplied by 2 to the power of 1, then 2 to the power of 2, and so on. The exponent's going to go up by 1 each time. I find this easier to think about rather than the exponent starting at the largest value and going down. But since I need to start with the smallest binary digit that's going to be on the far right side of my input, I do need my for loop to start at the large values and count down, right? If I've got 1101 right here, this 1 represents the least significant digit, value of 1. So 1 times 2 to the 0, plus 0 times 2 to the 1, plus 1 times 2 squared, plus 1 times 2 cubed. That will give me my integer value. And that is the calculation that I'm making here. So I start my for loop I at the length, the string length of the binary num. The bin num here is a string. Subtract 1 from that because I want to get an index that is actually valid. The length is not a valid index. Got to subtract 1. And I'm going to loop down to and including 0. It's important to include 0 because 0 is a valid digit. And I'll decrease the I to count down. So if the character at index I in the string is in fact 1, well then I should add in 2 raised to the power of exponent to my accumulation variable, my x, that's going to be my integer output. And regardless, the exponent is going to go up. The next digit we look at is the next higher exponent, and so on and so on and so forth. So that's my algorithm. I print it out down here. I do convert it back to string, which I think was unnecessary, but I did that anyway, apparently. And let's test this one out. I'll minimize that. I don't know if the background doesn't really make the background any easier to read, but that's okay. All right, that's the compilation. Here's the running. Enter your binary number. So I just said 1101. What was that value? So it's 1 plus 4 plus 8. So it should be 13. Great. There's 13. We can test easier things like 101, which should be 5, right? Yeah, 5. Okay. And we can test larger things that maybe I can't verify in my head, but 468, sure, that seems reasonable. At the very least, I know that it is even because the last digit is 0 rather than 1. If it was 1, it would be odd. But other than that, I don't know if I can't verify that in my head, but it seems like this is working. So we'll go back to the next file. I just did binary to decimal. Let's literally do the other one, decimal to binary. I do have my additional imports here. I actually don't think I needed the stack in the other one. I think I need the stack for this one if I remember correctly. And again, it starts off with that exact framework from before that I tested in isolation. Scrolling down, now I have added in, yeah, this is the only one I needed the stack for. I've added in just this code right here. It fits all on one screen. It's my algorithm for converting from decimal to binary. Okay, I used a stack here. That's maybe a little bit of overkill because what I need to do is I need to reverse the order of the digits that I end up with. So I'm going to calculate the digits from least significant to most significant, but I want to display them out, right? We write our numbers down from most significant to least significant. I hope I'm not reversed in the image. If so, just ignore my little waving hands in the bottom here. So I'm going to use a stack for that. There are certainly other ways to do it. You could just use a string. I'm pretty sure the string or string builder or some kind of string method exists for reversing, but I'm going to use a stack. Integer remainder is going to be a useful variable. So this is my while loop that really does the calculation. Most of the algorithm is right here in this while loop. This down here is just for reversing my result. So I have my decimal number that was typed in. As long as that decimal number is greater than 0, I want to get both the remainder when I divide by 2. So decnum modulus 2 gives me the remainder when divided by 2. And then also I want to get the result of integer division divided by 2. Now the difference between integer division and sort of your mathematical division is that integer division is not going to have any remainder. It's not going to have any decimal places. It's just going to chop that part off. What's 5 divided by 2? 2. As close as we can get. Now, is it actually 2.5 in standard mathematics? Yes, of course. But the 0.5, that remainder 1, can't be dealt with integers. Integers don't represent that sort of thing. So we just say, you know what? 5 divided by 2 is the question, how many times does 2 go into 5? Twice. And that's as close as we can get. And that's what we want to do for this calculation. Now, lastly, of course, I skipped over the middle line. That's where I'm going to put my remainder on the stack. That remainder, which has to be a 1 or a 0, there's no other remainder when you divide by 2, is going to be one of the binary digits for my number that results. All right, so then I basically just loop through and I construct a string by popping items off of the stack, which is going to give me the values in the reverse order that they were added, because that's how stacks work, right? The first thing you put on is the last thing you get out. And then I display the result. Okay, so what have I got here? Let me run that one and test it, even though that might be a boring part of the video. All right, so let me put in 5. I should get 101. There it is. What was the number I did before? 13? If I put in 13, I should get 1101. Perfect. What do we have? 468, I think? I forget. I could scroll up. Yeah, it's 468 right there. So that number, I'm pretty sure that's the same as this one up here. So yeah, I think that worked out right. Great. So it seems to work as best as, without further, more rigorous testing, it seems like it works. So I've got my two algorithms separately. They're in separate files. They work. I've also got the framework from the very first file that I showed you. Fantastic. Now all I need to do is put all of this together into a solution. I need to integrate the top-down approach with the bottom-up approach. So let's check that out. I decided to make the scanner a static variable because I'm going to use it in some static methods that were created. Scrolling on down, my framework is almost identical to the first one that I showed you. The only difference is, instead of just printing out that we're doing a decimal to binary conversion, I call a method. Instead of just printing out that we're doing a binary to decimal conversion, I call a method. This is a key point of organizing your programs. Is there a particular activity, a particular set of calculations that need to be done related to whatever you're computing? Put them in a method. A method should be a relatively concisely describable action performed by your program. For me, this method is going to convert from decimal to binary. Now, it's also reading in user input, which, maybe that should have been organized elsewhere, but for my program, that's where I'm putting it. Same thing for binary to decimal. It performs that calculation. Yes, it also reads input from the user. Again, probably in most situations, you would want to organize that differently, but this is how I organized mine. Scrolling on down, here's decimal to binary. I literally cut and pasted, or copied and pasted, the code from the example where I did my decimal to binary code. I copied and pasted it into this method. That's so very powerful. I knew it was working before. Now all I have to do is put it inside the framework that I need, the framework of this method. Everything is organized and still separated into its individual components. Same thing with the other method. Here's the other method down below. I copy and paste the code that does the binary to decimal conversion into this method. It's wholesale, just copying it right over. Now it's still organized into this method here. And again, scrolling back up to main, all I got to do is call the methods. So all that work I did early on, I think paid off in terms of organization and being able to put it together at the very end in an organized fashion while checking for errors along the way. Let's finally just go ahead and run this one, although I believe I've run it before already, so I can pretty confidently say that it works. Okay, which way do we want to convert? We'll just do one first, decimal to binary, enter your decimal number. I don't know, just putting that in. No, sorry, I did that backwards, obviously. I mean, sure, we could interpret this as 10,110, but that's not really what I was going for. Let's try that again. Decimal to binary, so I want to put in I don't know. I'm still just putting in some arbitrary number, right? Great, run it. Okay, I'm gonna trust that that is correct. Now let's convert from binary to decimal. And let's actually just type in the same number. Let's just even copy and paste it and make sure that it goes back to 368. Great, it does. I'm going to type the number 3, and that should exit the program. Bye-bye, and we're all done. So the point of this was to give you some ideas about how to organize your process, even for a relatively small program. You can think about it from the top down. You can think about it from the bottom up. In all likelihood, you should probably think about both. And design it in a way such that you can test it regularly along the way, and so that you can integrate the pieces together in a modular fashion. There are different modules that are organized into different methods, and we can just sort of have placeholders that later on we substitute for a call to a method that has the code that that placeholder was representing. Great, hope you enjoy the video. Bye.